Oh my gosh. Is this happening? Are we live? Can you guys see me? Can you guys hear me? Is it even grade school? I mean, it's actually somehow, after having to make one final delay on Friday of grade school, we're back here at our regular time, Monday morning at 10 a.m. Hi, everyone. I'm super excited to be back with y'all. Today, we're talking about nodes. We are going to talk about all the different types of nodes that are inside of Resolve, and I'm going to try to make you an expert in all the different types of nodes that you can use inside of Resolve. And I'm also going to reveal my favorite secret about nodes that's going to change the way you think about them, change the way you work with them here in today's session. So I'm super excited. My buddy Annie's here with me. What's going on, Annie?
Hi guys, I'm very excited to go node mode with all of you.
Node mode. Who's in the chat? Who's here? Who's with me? Tim's here. Who else? Oh, Chilembwe. Hey, buddy. Good to see you, man. Jim's here. All right. Lindsay's here. PK. All right. We got the gang together. Boy, oh boy, I'm glad to be back here with you guys. Let us know if you can hear, see, feel us in all of our high resolution, beautiful sounding glory. I'm coming to you guys for the first time from my new home office that I just finished kind of getting set up, and hopefully that means that we've had the chance to get all of the kinks and bugs worked out with streaming from a new machine in a new office and coming out to y'all over the YouTube airwaves, cable wave. I don't know how that works. Anyway, if you guys are having trouble hearing or seeing us, let us know. Or if you can hear us and see us beautifully, let us know about that too. Because not gonna lie, it took a little bit of extra effort this morning to get it all set up and running and working. Let's see. Okay, cool. Tim can hear everything just fine. Amazing. You guys want to talk about nodes or what? I'm excited for this session. We haven't talked about nodes explicitly in a little while, and it's kind of the building block of everything that we do inside of Resolve, right? So we're going to do a format that we've been doing more and more here in grade school. I'm going to talk at y'all for a little bit about nodes. I got some thoughts. I got some takes about nodes that I want to share with you. But get your questions ready about nodes, anything that you want to talk about, or questions that you have along the way as I'm talking. Make sure to jot those down because we will have time to take plenty of questions from everybody and talk about whatever is on your mind as well. But let me dive in because I got quite a bit to cover about nodes. So I'm going to get my node notes because we're in node mode. And we're going to start with some basics here. So here's like the number one thing that really helped me when I started to understand it about nodes. This is going to unlock the way you think about nodes a little bit. So pop quiz, question for the room, answer for yourself. How many different kinds of nodes are there inside of Resolve? Go ahead and rattle them off if you have to. Like think about all the different types of nodes there are inside of Resolve and different ways to create interaction between the operations that you're performing with your images. I'll give you just a second to think about that. The one thing that I didn't get ready in time for this session is my coffee. Guys, moving, does anybody like moving? Moving is like, I feel like it's gotten worse as I've gotten older and we have kids and stuff. We just got a lot of junk to move around and getting things settled and getting like, for example, coffee so that it's like nearby and I can make my normal morning cup of coffee. I feel like we're right on the cusp of that. We're like 3 days away from that being back into a regular routine. And I'm quite a creature of routine. That tangent aside, I'm sure I've given you plenty of time to answer my very simple question about how many different types of nodes there are. So I'm going to go ahead and say that probably nobody got my answer, came up with my answer when I asked that question. The actual number of different types of nodes there are inside of Resolve, are you ready? Drum roll please. There's only one. There's only one actual type of node inside of Resolve. That is what Resolve calls, if I wipe out my whole node graph here, let me get my screen share on. That is what Resolve calls a corrector node. If I right click on here and say add node, corrector. These other types, these would be the only exception, these mixer nodes or these nodes that allow you to split apart and combine your nodes, which we're going to talk about over the next few minutes. But these are not nodes in the sense that you perform operations inside of them. That's what I'm thinking of when I say a node. I'm thinking of one of these little squares that has a thumbnail inside of it and I can do stuff to manipulate the image, right? There's only one kind of node that allows us to do that. That's a corrector node. What we tend to think of as different types of nodes, parallel nodes, layer mixer nodes, split nodes, these serial nodes even, all these different types, these are actually nodes that have been set up with these type of things. These guys right here. Actually, I'm going to go over here. these guys, parallels, layers, keyers, etc., those other nodes that I'm talking about, parallel nodes, layer nodes, etc., those are still the same type of node as I have right here. They've simply been set up to interact with other nodes in a different way. But the node itself is not changing. Does that make sense to you guys? For me, that really helps to simplify and crystallize the conversation about nodes. And if that doesn't quite track, then don't worry, we're going to make it clear as we go along today. But that's the number one thing that I want to put forth for all of us to sort of change our concepts of. There's actually only one type of node, at least if we define a node as a thing that we perform an image manipulation inside of. There's only one type of node, and there are simply different ways that we can cause our nodes to interact with one another. Okay, so let's look at things through the lens of what are the different ways that we can cause our nodes to interact with one another. Okay, and an easy way to do that, by the way, before I go any further, I do have my color management set up in this project as I always do. I'm color managing a node, so I do have a color managed image that I'm working with here at the moment. And let's have some fun. What good is it to have a world-class look development plugin if you can't use it? So we're going to pull in a look development, or a look rather, so that we have a pretty image to look at. I'm using my look development plugin Contour, and I'm going to use actually we're not going to use secret sauce. We'll use Film Print 1, just so that we've got some vibe while we're taking a look at our nodes. All right, so this is going to be our look, and let's go back over here to the clip level. And we're going to now talk about the different ways that we can cause our nodes to interact. So let's just say we're making, like, I don't know, I'm doing like a lift up, gamma down, maybe gain up type of thing, like a very common type of correction that I make to kind of like thicken up the image, but also open up the image and make it a little bit more popping, if that makes sense. So what are the different ways we can cause our nodes to interact? So this would be adjustment 1. And let's say we're going to do one more adjustment. And in this one, we're going to do, just to keep things simple, I'm just going to do an offset and cool things off a little bit. Now, something feels weird here. Okay, I'm just stoned. I'm just not used to using offset, I guess. All right, so we've got our color balance and we've got a tonal adjustment happening here between nodes 1 and 2. What have I done so far? What kind of nodes am I using? What type of connection have I created between these nodes? Again, that would be the sort of like tangible example of what I'm talking about. These two nodes, there is no way I can change what type of node this is. This is a node where I'm making these lift, gamma, and gain adjustments. This is a node where I'm making these offset adjustments. What I can change is the way these nodes interact. What are some ways that I can change the interaction between these nodes? Well, if I go to node number 2 and I hit E to extract it, I can move node number 2 upstream and put it in front of node number 1, right? That's going to change the order of processing. Right now I'm working in serial nodes, right? That's serial as in S-E-R-I-A-L, not serial like Captain Crunch, although I kind of wish there was a Captain Crunch node as well, because I'm still 7 at heart and wishing that my mom would let me get the Captain Crunch when we go to the grocery store. Anyway, I digress. So we've got our serial nodes here, and we can change the way they interact by changing the way that we sequence things, right? Because now I'm feeding a different balanced image into this tonal adjustment than I was before. Sometimes that matters a lot. Sometimes it matters barely at all. If I like grab a still of this and then go back to what I had before and we wipe between the two, let's make sure I'm wiping full frame with these. And you look at the vector scope, it's making virtually no difference whatsoever, right? So in that case, it is not a significant change. But that's one example of the way we can change the interaction between these nodes. Let's look at some of the other ways that we can change interaction between our nodes. So we can create a mixer, right? We've got two different types of mixer that we can use. We could do a parallel mixer. Let's start with that. So we've got a still grabbed of, let's grab a still actually of this version, our original version. And I'm now going to, once again, extract node number 2. And here in node number 1, I'm going to tap on and hit Option P. And that's going to give me a parallel mixer structure. Now, again, I just want to clarify as we're going along what I mean when I keep saying that there's only one type of node. Normally, conventionally, when we are talking about node graphs inside of Resolve, when we talk about this node structure that I've just created here, we would typically call nodes 1 and 4 what? We would call them parallel nodes, right? And that's fine. I'm not even necessarily suggesting, oh, that's terrible terminology and we shouldn't use it anymore. I'm more suggesting a shift in your concept and a shift in your understanding that you can call these whatever you want, but these nodes and their behavior are not actually changing. What is about to change here is the interaction between these two nodes compared to the way I had them set up in serial a moment ago, okay? So if I now drop node number 2 here into this piece, I've now got these same two adjustments, but they are happening in parallel with one another as opposed to in serial with one another or in sequence with one another. That simply means that they're happening at the same time. And I'm going to throw you guys right into the deep end. Like, we're going to get geeky today. So first of all, I want you to observe, like, when I wipe to this previous version of the image, in this case, there is no difference between a serial node and a parallel node, or between a serialized version of these adjustments versus a parallelized, can we say that? Parallelized version of the adjustment, right? That doesn't mean that will always be the case, but that is something that's worth pointing out. In my book, The Colorist 10 Commandments, I talk a lot about looking for simplicity over complexity and always looking for the simplest possible solution. Simplest possible solution, if we think about like the way that we create interactions between our nodes, the simplest possible interaction that we can create is the one that we already have, which is simply to say we do A and then B and then C. That is a serial adjustment, right? If you do not need more complexity, as in parallel nodes or layer nodes, you should not avail yourself of it, right? Because all you're doing is adding complexity. And parallel nodes, I actually want to talk about right now because these are one of the most fun bits of, like, elegant bit of kind of colored math that exists anywhere inside of Resolve. What it's doing here is really, really neat. And we're going to see it's actually quite a bit more complex than it seems, and definitely quite a bit more complex than a simple set of serial adjustments that go from A to B to C. So here's the math. What's going on inside of a parallel node? So essentially what we are doing is we are taking an input, we are modifying it so that we have an output, right? So that's what's happening here in node number 1. So this is the output of parallel node 1 is equal to basically what we're going to do at the input point here is we're going to take the difference between the output and the input, and that's what this parallel node stack is going to process in here. Let's should we get geeky and just kind of jot this out? Can I do this? Let me go unfull screen from Resolve here. I'm just going to give you guys like some simple Sublime text notes. So let's say parallel mixer. So the logic here is we're going to say out P1, for example. That just means that the ultimate result, what we're going to take in here at the input of our parallel mixer from the first input here, out P1 is going to be equal to the out of node 1 minus the in of node 1. It's doing a difference mode. And we're going to talk about difference modes or subtraction modes in just a second when we talk about layer mixers. But it's literally just performing math. It's going on a pixel by pixel basis, take the output and subtract the input pixel. Whatever that difference is the result. Okay? Stick with me. I know this is geeky, but it's kind of fun. And if you don't follow everything that I'm talking about right now, that's also cool. You probably, well, I'm not going to say you probably won't. I definitely didn't the first time I learned this. So it may be the type of thing that has to wash over you a few times before you get it. But regardless, this is kind of a fun little bonus Easter egg for those of us who enjoy and appreciate and use parallel nodes to recognize just how elegant and actually kind of complex they are in their construction to allow us to do what they do. So that's our out P1, all right? Now, we can have as many parallel nodes as we want, right? So we're going to say, just for example, out P2 equals out of node number 2 minus the in of node number 2, okay? And now let's call this out of the, like parallel, like parallel all. What are we going to do with that? All we're going to do is take out P1 plus out P2 plus out Pn, however many outputs we have from however many parallel nodes or like nodes we had set up here. And then what are we going to do? We're going to add back in our original input, the original input that's feeding into all of these nodes. Does that make sense? If it doesn't quite, it's okay. But I kind of like to detail this out because this took me a minute to figure out, by the way, when I first went in and started digging through it. And I was really motivated to, though, because I was like, wow, this is really kind of magical. Like, if we look at what is the net result of all of this math and stuff here, the net result is that I can make a bunch of adjustments that are not dependent on one another, okay? So one of the things that I found most confusing about parallel mixers when I first started working with them is that unlike layer mixers, they have no sense of hierarchy or priority, okay? So remember I pointed out like, oh, in this case right now, my serial implementation, my serial node implementation of these two adjustments versus my parallel implementation actually carries no difference. That will not always be the case. If it were, we would never use parallel nodes, right? There are many instances where we can get better or different results by having things happen all at the same time and then coming together as they do in a parallel mixer versus happening A after B after C after D, or rather A followed by B followed by C followed by D, etc., right? So when we mix them together in this way, in a parallel node, one thing that is equivalent is if I do this. If I take node number 1 and I pipe it into this input, and I take node number 2 and I pipe it into that input, that will always give me an identical result. I can mix and match these things together in any way I please, and there will be no change because there is no hierarchy, because I am simply adding these things together and they're not being added with any difference in priority or math based on their visual position in the parallel node mixer. Okay? And again, I want to emphasize when we talk about the true like different types of nodes there are, this is a different type of node. It's not what we typically think of as a node because it's just a processor. It's just processing input and producing output, but we don't get to intervene at all as the colorist, right? So that's why I tend to think of there being one single type of node. Okay, are you with me so far? I kind of, note for Colin for next time, I'm probably going to start with layer mixers the next time we talk about this. That's where we're going next, but layer mixers are a little bit easier to understand maybe than parallel mixers. Parallel mixers are a lot to bite off. Maybe I feel that way simply because, like many of us, I come from a layer-based background. Like I was using Photoshop and Premiere and Final Cut Pro long before I was using Resolve, so the layers just make sense in my brain. After Effects, for that matter, everything kind of, I came from a layer-based background. This world of like, oh, it looks like a layer, but it's actually not a layer at all, takes a little bit more mental effort for me to kind of like make sense of it. But if you've held on thus far, then great job. We got over some of the most complex stuff right off the bat. If you haven't, you can go rewatch this recording and hopefully you'll be able to make better sense of it on a second or third review. Okay, so this is one alternative way that we can cause our nodes to interact. We can cause them to come one after the other in serial. We can cause them to be mixed together in parallel, in which there is no like vertical priority to things. We're simply saying, take the difference between the input and the output of whatever adjustment I've made and do the same for every single node in that stack, mix those all together, and then add in the original input, and that produces a parallel node, produces really cool results. Last thing I'll mention about parallel nodes, I actually did a video on this here on the channel some time ago. This math, this implementation that I just talked about, it works beautifully well for any per pixel operation. Per pixel operations are most of Resolve. I'm not going to say most of Resolve. It's most of what I think of color grading as. It's most of what I do in a color grading session. It's my primaries. It's anything in my HDR palette. It's my RGB mixer. It's my custom curves. It's my color slice tool. It's anything in those categories, like manipulating things on a per pixel basis. Anytime you are getting into textural things, where you are manipulating things not only based on that specific pixel, but based on the pixels around it, examples of this would be noise reduction, blur, mid-tone detail, any kind of texture. I'm having total dad brain now. What the heck is it called? Yeah, the texture pop here inside of our Open Effects. These are all things that are not just looking at each individual pixel and doing a thing to them, which is what happens like with our gain, for example. Gain just says, hey, whatever the pixel is, whatever the red, green, and blue components of that pixel are, multiply them by whatever the user specifies here. So right now I'm multiplying each of them by 1.2. Gain has no notion of whatever pixel came before or after the pixel that it's currently evaluating. When we talk about textural operations, that's not true. They are changing their behavior based on adjacent pixels, okay? When we're doing anything textural, anything spatial along those lines, parallel mixers can get us into trouble really fast. So that's a really good thing to call out. Parallel mixers are magical. They can allow us to do things more cleanly and without having to serialize them when that's advantageous to us. But one thing we never want to do in a parallel node structure is anything textural. Again, that would be blur, mid-tone detail, noise reduction, grain, halation, any type of thing that is dependent on adjacent pixels in order to produce its result. Okay? For that, you're better off going back to the humble old serial node. You can even see this in my template node graph here. I have a dedicated node for texture things over here. I love parallel node stacks. I've got 2 of them right here, but I've got a dedicated node for doing textural stuff over here because I've learned the hard way that cannot live inside of these stacks without sooner or later leading to problems. Okay, let's talk about parallel, or excuse me, we're done talking about parallel. We're never talking about parallel nodes again. I'm kidding. We're going to talk about layer mixers now, okay? Layer mixers, most of us probably have some amount of familiarity with. A layer mixer looks basically identical to a parallel mixer. But let's once again go with our experiment of looking at different arrangements of the same nodes. So this was our parallel node structure, right? And when I wipe between the parallel node implementation of these 2 adjustments versus the serial node, as we already saw, there's really no difference, right? But check this out. What if I right-click on this node and I say morph it into a layer mixer node? Let's see what's going to happen here. Well, that's making a significant difference, right? In fact, what this is doing, because this is a layer mixer node and the blend mode that we're going to look at in a moment is set to normal, all that I'm doing is creating a hierarchy, a priority based on the vertical position of the node here. So strangely enough, in Resolve, lowest node takes highest priority. So right now, all I'm really seeing is node number 2. I'm not actually, node number 1 is contributing nothing to the image that I'm looking at right now. So much so that if I select node number 1 and I hit delete, watch the image, or better yet, watch the scopes. No change at all, right? Because node number 1, or rather node number 2, is completely blacking out node number 1. I'm only seeing the results of node number 2 because my composite mode is set to normal with the layer mixer, okay? Now, there's a couple of really fun things that we can do with layer mixer nodes. Maybe the simplest one before we even talk about blend modes, you guys might have seen this because you can use it not just in layer mixer modes, but anywhere inside of Resolve. If I go to my key here and I set my key output gain to say 0.5, now it's literally like I am creating transparency in this node. Now I'm getting 50% of the full strength of this adjustment, and I'm seeing through this node 50% down to node number 1. So now node number 1 does have an impact on my image. You can see as I make this adjustment, it's changing it, right? It's changing it at half the strength that it would be if there was no layer node over on top of it, but still we can see through it, right? So that's one way that we can create interactions with our layer mixer node, because that's really what it comes down to, is like you create a layer mixer node and you're like, okay, great. If I have my composite mode set to normal and if I have my key output gain set to 1, nothing matters except for the topmost node. Well, that's kind of boring. What's the point of that, right? Not much point. That's why we need to either start playing around with key output gain, or we need to start playing with composite modes, which is where we are going to go next. So in this same node, now that I have morphed it into a layer mixer node, I have this option of a composite mode. Now the composite mode, this is maybe the most literal application or expression of the idea that we started our conversation with, that there's only one type of node and all we can do in Resolve is change the relationship between those static nodes that we've created. Here I can change the way that these nodes interact with one another. And with all of these, it's essentially going to mix these different elements together with the mathematical formulas that are coming from each of these different blend modes here. By the way, if you want to actually know what the geeky math is here, kind of like to the same level of detail that we just talked about parallel mixers a moment ago, you can go to like Wikipedia and look up blend mode math, or just Google blend mode math. These blend modes are common to like Photoshop and pretty much any software that uses layers, and they'll all tell you what is the explicit math that's being is a couple of simple blend modes here that allow us to do what I've called in the past visual math. This is kind of like a side entrance to the world of color science for anyone who's interested in getting into that world but doesn't necessarily want to bite off code or go start reading 700-page textbooks. This can be a really fun way to kind of visually start nibbling at the edges of the world of color science. I'm going to give you an example here right now. So we've got all these blend modes that, like, by the way, I don't know, like, have committed to memory what the math is for all these blend modes by any stretch. I, in fact, don't know what most of them are. But the ones that I do know, I can point out right now. Add, multiply, subtract, divide, and difference. Why do I have those committed to memory? Because they are what they say. What do you think add means? Add simply means I'm going to take the bottom node and add it to the top node. So the image is going to get a lot brighter, right? I'm literally going to take the entire processed image from node number 1 and add it to the processed image from node number 2. That's it. What else do we have? If we look at like subtract, for example. Well, with subtract, I'm going to do the opposite. I'm going to subtract one from the next. I'm actually not sure why oh wait, that didn't take. There we go. Oh, I think I flipped my composite mode here in my node, which we can talk about if we have time at the end, but for now I'm going to ignore. Let's flip that back to normal. So I've subtracted one from the other, and because there's not ultimately that much difference between these images, my frame is almost black, right? Like you can see there's some life down here in the histogram, but in terms of the image, it's pretty well gone, right? It's almost black. So those are just a couple of examples. Multiply, same kind of thing. With multiply, I'm going to get more contrast because values that are below 1 are actually going to get smaller. Like if I multiply, I don't know, 0.5 by 0.5, what do I get? 0.25. So the value actually goes down. So it's going to cause the image to get darker. So we've got all these different blend modes, but within them, we've got a couple of very straightforward, I am what I say type of blend modes that we can start to do really cool stuff with. I'm going to give you like one simple example here just to give you a sense of what I mean. So check this out. We've talked here on the channel plenty about HSV saturation, right? And about the magic of it and how we can use it to create more organic feeling, more filmic feeling saturations, right? But I want to show you something here where we're going to do that same thing, but we are going to use layer mixers. So check this out. We're going to do a color space transform, like so. And I'm going to say DaVinci Wide Gamut, DaVinci Intermediate. We're going to go to HSV, and then I'm just going to go to DaVinci Intermediate. This part actually doesn't matter when we're going to HSV, just FYI. And we're going to cheat a little bit. We're going to use another type of node that we haven't even talked about yet, but this is a really good way to introduce this node. That's a splitter combiner node. A splitter combiner node just takes the 3 color components of our image and splits them off into monochrome channels. So if this image was still red, green, and blue, this splitter combiner node, if I hit Option Y to create it, it calls it a splitter combiner node. Again, this is like, you don't have to change your terminology, but you do need to change your concepts a little bit. There's actually no such thing as a splitter combiner node. There is a splitter node and a combiner node. They're separate nodes, and you don't actually have to use both of them right next to each other or both of them at all when you're working in Resolve. We're going to see an example of that in just a second here. But if we look at this, all I've done is split apart temporarily. Here's my red, here's my green, and here's my blue channel. Red channel, green channel, blue channel. And as long as we're here on splitter combiners, we can do some interesting stuff. Like we can look at making adjustments just to our red channel, like just changing the gamma of my red channel. So this can be a kind of fun, intuitive way of creating some different balance in our image than we had before. Like that's kind of nice, what I'm doing right there, right? I don't really know what I'm doing other than kind of like creating some more coolness up in the top end of the image, but I like it. So that's what a splitter combiner node does. It splits everything apart, lets us operate on each individual channel. In this case, those individual channels are red, green, and blue. Red, green, and blue. And then it puts them right back together into its red input, green input, and blue input. All right? Let's go back to what we were doing before with setting up our fancy bit of visual math here. So I'm moving this into HSV. That looks totally batty, doesn't it? That's because I'm now looking at my coordinates in terms of hue, saturation, and value, and that is not what my display is expecting. It's expecting amounts of red, green, and blue, right? So here's what we're going to do. I'm going to label this as I go along. We'll say we're going to HSV right now. I'm going to delete this node because I don't even need it. And what we're now going to do is add a couple serial nodes just so I've got some nodes to work with. I'm going to tap on node number 3 and extract this just so I've got a fresh node up here. I don't even need this one actually. And what I want to do now is, again, I'm separating out channels 1, 2, and 3 when I create my splitter node. You can see I've already gotten rid of my combiner because I don't need it right now. So I'm going to disconnect this and I'm going to connect this node to receive its input from node number or from channel number 3. In that case, in HSV, that is the V. That is my value or my brightness channel. The V channel is kind of what makes HSV when we use the saturation trick. So here's what we're going to do. We've got this pulled in, and we're now going to do a layer mixer. We're getting kind of fancy, right? So check this out. I've got my layer mixer here. I'm going to try to kind of keep this organized as we go along so it doesn't get completely nuts. Let's label this as my V. And I'm now going to take this node and I'm going to have it take its input from elsewhere. I'm going to say, I want you to take your input from before I even went into HSV, way over here. And now I've got this layer mixer where right now, if I turn off my highlight mode, all I'm seeing is that V channel, because in my layer mixer, my composite mode is normal and I have no key output gain at all, right? But check this out. I'm going to change my composite mode now to subtract. What's that going to mean? That means that my V channel will be subtracted from my original RGB, okay? What do I have right now? Basically nothing except for a little bit of life here in the histogram. Stick with me. We're going to do one more piece to the setup, and then we're going to have something kind of interesting to work with. Again, I'm going to try and kind of keep this as organized as I can for us as we go along. So this is our V channel. Here's our subtraction operation. Here is where we're going to actually do stuff in just a second. But for now, we're going to add another layer mixer node. Option L is how I'm doing that, by the way. And with my layer mixer node, what I'm going to do is take what I've done down here and add to it what I originally had. So if we look at the logic of this setup before we even start talking through what we're going to do within this setup, what do we have? We have an RGB image from which we are subtracting our V channel from HSV. That leaves us with RGB minus V, whatever you want to call it that, whatever you want to call that. We're going to do some stuff to that, and then we're going to add that original RGB, or excuse me, we're going to add that original V right back to the image, okay? So I'm actually doing this wrong because this needs to pipe into here to my value, like so, okay? And for this one, we need to change our composite mode again. We're going to do a composite mode of add, okay? And now, here's the part that is, spoiler alert, and pretty much anytime you're doing anything with creating like kind of fancy node setups like we're doing here, first thing you want to confirm is that you have a do nothing. So if I reset all this, that looks the same as what I have here. That's what I want because I don't want the setup to change things. I want my adjustments within the setup to change things. And now that I've done all this, what does this leave me with? This leaves me with a single node that I can adjust. My saturation's on. So now I can adjust my saturation effectively in an HSV-like space because I've subtracted everything that is not color by subtracting my value out of it. Now, you don't need to build a node graph like this for this particular application because we can do this in a single node as we've talked about here on the channel before. But this is one of the simpler examples that I was able to think of that allow of things you can do with layer mixers that allow you to start exploring the math and the science of images in a visual way inside of Resolve. So just as a quick recap and in case you're trying to build this for yourself, color space transform from my working space to HSV here. Splitter node here, in which I take the third channel, my V channel, and pass it forward into a layer mixer, which is mixing in with the original image before the color space transform happened at all. At that point, my composite mode is being set to subtract. I'm saying subtract this V channel from my starting point RGB, okay? Operation will happen here in node number 7. Once I am done operating on that effectively saturation channel that I've created, I'm going to create another layer mixer structure in which I take that adjusted, modified image here, and to it I will add that original V channel that I subtracted out a moment ago, okay? All I need to do that is set my composite mode to add. That's just one example, and in this case an example that's not necessarily one you need to apply in a practical sense because you can do this more easily. But it is an example of using the layer mixer to apply visual math and to get a deeper understanding of what's happening in an HSV node, for example. If you're able to do this, if you build this, if you're following along with my example right now, you understand more about HSV saturation than you did before, would be my suggestion, my contention to you, okay? So that's one example of cool stuff you can do with the layer mixer and starting to understand the math and the science of images in a bit of a deeper way than simply using serial nodes, for example. Okay. I got one more thing I want to show you guys, and then we can talk about whatever's top of mind for y'all. So we've now talked about parallel mixers. We've talked about layer mixers. We've talked about splitters. We've looked at splitters here in this case, and you can see and we also talked about combiners more briefly. That if I just do option Y here, again, I can recombine these things after I've manipulated them on an individual basis. We just happen to do something a little bit even more advanced than that in our prior example. You can also, of course, do zany things like say, oh, I want to pipe my green into my blue and my blue into my green, right? That's going to give you a whole other rendering of your image than you had before, right? So that would be using the splitter combiner node to do some interesting things. That is where it starts to get sort of like a less fine-toothed RGB mixer type of thing, an RGB mixer with less control. Okay, so don't judge me, I'm drinking a Coke Zero. Let me see what else I wanted to share with you guys. I think that's about it. The last thing that I wanted to share with you guys, believe it or not, we have now touched on every possible way to change the behavior of an adjustment that we make. Again, I feel like that's the way that it finally clicked and made most sense for me when I started working with node graphs in more detail, is thinking about hey, any node and anything that I do within that node, the only way to alter its behavior and its relationship to the rest of the node graph is with the things that I'm showing you guys right now. There's no actual difference in the node itself. It's just the context that I create for that node. And we've talked about the context of serial, the context of parallel, the context of layer mixer, the context of being inside of a splitter or a combiner node. There's really only one other way to change the context of a node that we are adjusting that we've yet to talk about. Anyone want to take a guess what that is? You can think about it to yourself for just a second. I wish we were in less of a laggy format than YouTube Live provides for us so I could actually see your answers. But think about it for just a second before we answer. That would be using a key, okay? So let's once again go to our same base adjustment here, and let's focus in on the tonal adjustment. So one simple way to change the context of this adjustment would be right within this node to use a qualifier, right? I could do have I told you guys this? I don't know, it's not really this is maybe not really a joke. Maybe we could call it a dad joke, I guess, that I've got here at my home office, I have the Resolve Mini panel, which I actually love. I have the advanced panel at my office, and I feel like the question comes up all the time of oh, have you gotten quite fluent in both? And my answer is always I feel like I've gotten equally uncomfortable with both because I'm always flipping between them. So I'm always pressing the button for whatever or reaching for whatever button is on whatever control surface I'm not actually standing in front of at the time. But anyway, if we look at doing a luminance qualifier, I'm going to turn this highlight mode off, and let's do something just to make it more extreme. Let's say it's a big cool wash, for example. If I turn this luminance qualifier off and then on, that's really changing the context of this same adjustment that I'm making over here in my primaries, right? Seems obvious, but it's worth kind of calling out explicitly that this is a qualifier that's saying, hey, you must meet the following conditions in order to receive the adjustments that are happening within this node, right? So this is an example of pulling a key right within the node itself and making an adjustment. The only other variation on this, the only other way that we haven't already discussed to change the context of an adjustment inside of our resolved node graph is to pipe a key into that node. So maybe the simplest way to look at this would be to copy this node. I'm going to prepend another one by hitting Shift-S and go to Command-V. And in this one, I'm going to wipe out the primaries adjustment. So this is just a key that I'm pulling. I'm actually going to go ahead and disconnect this connection here and run things like so. So I've got this kind of like dead stump over here that is not going to be, it's not passing forward into the node graph at all. Up here on node number 1, I'm going to make a change as well. I'm going to wipe out the qualifier. So right now, I just have this primary adjustment that's happening, right? But check out what I can do. In this key that I have pulled or I have created, which I can create in all kind of different ways, I can pass this key forward by grabbing the blue square and passing it forward to the blue triangle, like so. And now I've got exactly what I had before, but the key is being pulled outside of the node that I'm actually making the operation or the adjustment within. And this is a whole wide world. You can create and produce and input mats or masks in all kinds of different ways inside of Resolve. This is one of them, which is literally to pull a qualifier and then pass that mask forward. But you can do all kind of other zany stuff too. Check this out as kind of a last final example. Let's do a splitter node. I'm going to get rid of my combiner, get rid of all these pieces, pipe this back into here, and I'm now going to use my red channel as a mask into my balance adjustment over here. So now I'm only affecting the red channel with this adjustment. That's kind of cool, right? So there's lots and lots of power in terms of like how you can start to creatively think about what type of mask sources might be interesting to feed into this adjustment or to limit this adjustment, right? That's a whole other galaxy. We could do a whole other hour session just on interesting ways to source and derive masks. But I'll leave you guys with that thought to explore further, that like the last way to really change the context or the end result of an adjustment in what we now know is one type of node that we are always grading inside of Resolve. The only other way to make a change to that context and a change to the end result that we're getting that we haven't already talked about is with what we pipe into our alpha channel here, or with using something that's going to produce a mask that the node is limited to right there within the node. Okay, I hope that's helpful for you guys. I hope that's some interesting ideas and maybe a bit of a different take and different way of looking at some of the node basics that you might already be familiar with, or maybe this is all brand new to you and I'm blowing your mind or completely confusing you, and if so, you can let me know and we'll try to clarify in the next few minutes. Let me shut up for a minute. What questions, what ideas, what stuff do we have coming up as we're talking about all this stuff about nodes?
Yeah, we have some comments and images, metaphors here that I think would be interesting to talk about. Maybe less question, but you know,
Cool.
what is a question anyway? Thatcher is saying the parallel mixer looks back at the shared parent of all of its inputs, which is pretty different from most other tools.
Yes,
Just one thought out there.
I like that, the shared parent. That's right.
Jim Robinson. The layer mixer, I usually explain that it's like animation cells. Background first on top, and then each layer below is an overlay, like animation cells, versus a Photoshop explanation.
You know what? I like that one, and I think like I'm glad you bring that up, Jim, because I think to me the biggest kind of like gotcha with the layer mixer is it's kind of two things, right? That's exactly, I think that's a very appropriate and very like illuminating metaphor for the layer mixer when it's in normal. When it's not in normal, it's really tough to conceive of it, even though there still is, there's not so much visual priority as like, you know, like the order that your nodes are in a layer mixer always matters, even if you're not in the normal mode. But it's not a straight up priority when you move into those different composite modes, which of course there's only one normal blending mode and there's like 20 of those other ones. So I think that analogy holds, but I also think it's worth calling out. Like this is a part that I would love to hear from anyone if they've got the perfect answer or something they like for it. What is a concept or an image or a metaphor that we can use that sort of wraps its arms around all of the layer mixer, including when we're using all of these kind of geeky and potentially complex blend modes?
Jim is also bringing up the idea of using the splitter to check noise, which is usually mostly on the blue channel, and then adding noise reduction to that channel.
You know what, Jim? I haven't thought about that in such a long time, but you're totally right. That's something that like I remember having someone show me pretty early in my color grading career and kind of being blown away by it. Specifically to check like relative noise levels. Like I'm wondering if I look at some of this like moodier night stuff. Oh, I've got some disconnected images. That ain't right. I'll have to reconnect those. Like, let's look at this moody ass red frame from my buddy Joe's movie. Yeah, if we like scrub through this, because I think the light is gonna, well, actually it looks like I've just got a single frame here. But in the context of the frame, this is like, it's an evolving frame that the light comes up on. So it's not just a case of like, oh, you forgot to expose it. But this is probably gonna be a great example of like, if we do a splitter combiner node and we look at what we've got in each of these channels, like the red channel has everything, right? Green channel has a lot less, and the blue channel has about the same amount, right? And if we zoom in, you can totally see, like, yeah, that's where I'm not seeing much noise in the red, but I'm seeing some in the green and even more in the blue. So that's a great thing to call out. And this also means like the technique I was alluding to that someone actually showed me years ago is like you can potentially get a sneakier noise reduction just by, does anybody else ever reach for the color slice thinking it's noise reduction? I can't really like explain why. They don't really look that similar and they're not really that close to each other, but I do it, like not that infrequently. But if we look at like doing, you could do potentially some more aggressive noise reduction just on this blue channel, but have it be overall less noticeable because you're not hitting all channels, you're just hitting the noisiest channel. So yeah, great point. Glad you reminded me about that. Glad you reminded all of us about it.
Thatcher was mentioning that the luminosity blend mode becomes kind of strange, particularly when you lower contrast in that node. Interesting thing to note.
Oh yeah, I mean the luminosity and the color blend modes do interesting stuff, don't they? Like if we look at the, tell me again what was the recipe there, Annie? Was it lowering the contrast in the first node?
Yeah, lower the contrast in that node. Didn't say which one exactly.
Got it. You can chime in, Thatcher, and let me know if I'm running the experiment correctly. Oh, I think I know my answer there. Yeah, so like we are basically, as the luminosity and in fact the color modes are designed to do and resolve, we're affecting contrast. Where contrast, or I'll give you guys a fancy color science word that I hope I'm using and pronouncing correctly. I think I am. Contrast and color are now orthogonal to each other, meaning they don't interact. Like reducing contrast does not cause a change in saturation, as opposed to like if I reduce contrast in a normal node, you can see my vector scope is wildly changing, right? Like it's shrinking down basically to nothing as I make that change. So yeah, like if you have these things separated out, it can be really powerful. But if you are not being mindful of what you're doing, you can end up with very uncanny results like this. A more like functional version of this that we've talked about on the channel here before would be like doing your luminosity and then applying a LUT in just one of these two layers. So let's go to like, I don't know, I'll load in this one. So here would be applying this, and just to make things easy, let's turn our look off for now. So I'm now making this adjustment, but just on the, I'm just getting the tonal dimension or aspect of this LUT as opposed to the full shebang. Because the full normal LUT, let's grab this still, the normal LUT would look like this, right? But that still didn't grab for some reason. I went too fast. Let's try that again. We'll reset and we'll do this. So the full LUT would look like this, but in luminosity mode with just the top layer of receiving that LUT, it looks like this. So full LUT, luminosity top layer. Full LUT, luminosity top layer. And you can do it the opposite way too. You can take this, let's wipe out this little primary adjustment here. But you can take this and paste it onto node number 1 and remove this LUT from here. And now I'm getting just the color component of it, which kind of goes to what we were, Thatcher's point from a moment ago. That's like, yeah, you can definitely push that too far and kind of tear the things away from each other in a problematic way. But this is also interesting that I'm now getting just the color dimension of this LUT without actually imparting any change in contrast to the LUT. So luminosity and then its cousin color, which is basically going to do exactly the opposite, Like if I set, we can actually confirm, I'm about to make a claim here that I'll prove out. So if we have our luminosity mode set to, well, if we have our blend mode rather set to luminosity, and on the top layer we're applying our LUT in order to just get the color. If I swap these, like so, and I now set my composite mode to color, I should have the same thing. And indeed I do. So they're kind of like evil twins of each other. Color gets just the color piece, luminosity gets just the tonal or the contrast piece of it, and you can do fun things like you apply a LUT to one but not both components of the image, or you can mix them together in kind of an interesting way. Last example that we'll do here. Here in the color mode, it's like, well, what if I want some of this adjustment here? Let's take this. I'm now getting the contrast of the LUT as well. It is worth pointing out, like, even though I've got this blend mode and I'm applying the LUT at full strength in the tonal and in the color components of the image, it's actually not quite going to be identical to just applying the LUT straight up, if memory serves. Well, actually in this case it is, but I feel like it may not always be. But regardless, it's going to be pretty close. But if we look at this in this way, I can say like, all right, I want some of that contrast, but maybe not all of it. Like, let's do half. And now I've got half the contrast and all the color. So that's a fun way of kind of like, almost like audio mixing comes to mind, like writing the levels of these different aspects or components of the image can be an interesting thing to use those blend modes for. What else?
Changing gears a little bit. Okay, wait, where is this? How would you create a black and white IR look in Resolve when the footage is not shot on IR?
You know, I feel like, actually, Thatcher might even be able to check me on this. I feel like this is a conversation that has come up in our Discord before. And ultimately, it would be hard to say because, like, infrared light is not going to be captured by your camera sensor unless you're removing the low pass filter, or unless you have like an IR filter or mode being turned on in the camera. So it didn't see that light. So there's no way to know from red, green, and blue what the infrared was. It would be kind of like, this is not a perfect example, but like with like a Technicolor 2 strip, for example, it's like, well, we don't actually know what a third color sensitive layer would have seen sensitized to another wavelength of light because it didn't capture it. So all we know is what these two layers that we did have in the camera, what those captured. So I don't exactly know, like in any sort of like rigorous way, how you would go about that. And instead, like, I think it would be more a matter of like creatively looking at images that are of the type that you like find relevant and like embodying that IR look that you're after, and then kind of creatively grading things, starting with creating an overall look ideally, but more like creatively grading things to match that, and using your eye to say like, oh, I like how in this reference that I'm looking at, I like how these things become bright and really stand out, and these things recede and become really dark, regardless of whether that's actually what an IR capture would have seen. So in that case, like just to make a sort of practical example of it, if we do, you know, like the easy way to do this, we are switching gears here, but pretty good roundup on nodes there. And if you guys have other questions or final thoughts on nodes, then we can still have another minute or two after this one probably. If I flip this to monochrome in my RGB mixer here, what I can do here in a really simple way is change my weights of my colors. So right now, like red weights really high. It does not, it becomes very bright in this monochrome rendering. In this, red weights really, really low. So it's a matter of like, if the image wasn't shot that way and it wasn't really designed that way, it's probably something that you won't be able to get a ton of at the look level. Like you might even just want to ride things shot by shot and look at how can I use my relative weights that I'm allowed to do in my RGB mixer here in order to foreground the things that I want the viewer to look at, and to sort of like downplay or diminish or recede the things that I don't want the viewer to look at. And then because just like I don't know what the infrared camera would have seen because this wasn't shot that way, the viewer doesn't know what was truly an infrared stimulus versus what wasn't. All they know is what you're showing them. So if it's being rendered in an IR style and something is bright, that means it had high infrared value, right? And if it's dark, it means it had low infrared value, and they've got no choice but to accept that, if that makes sense. So it can be kind of a fun creative exercise if you're like, hey, you didn't shoot it that way, you didn't design it that way. I have no way of actually knowing what had high versus low infrared energy. Instead, you can just go to monochrome and use your relative weights to basically tell a better story, if that makes sense. That's kind of how I would think about that.
Okay, back to nodes. What is the difference between using a layer mixer with a composite mode versus a serial node with a composite mode set?
Oh, that's a great question. Yeah, so let's talk about that for a second. I'd forgotten that we touched on that a little bit earlier today. So there's no inherent difference there. Like let's just do a quick experiment here. Let's say we're doing the little exercise that we brought up when we were talking about some of Thatcher's points earlier. I'm just going to do a luminosity blend mode of this, like so. So what am I doing right now? I am applying this LUT verdigris at full strength, but only to the tonality of the image. I'm not affecting the color of the image by doing this, right? Let's grab a still of this. Let's now reset everything, set the composite mode of this node to luminosity, and apply the same LUT. What difference am I going to see between these two? None, right? There's not going to be any difference whatsoever. So what this is really doing is, what it can mimic is a setup like this, in which I love using the composite modes on an individual node basis. And it really just has a couple of baked in limitations that for many applications are totally acceptable. The limitations are that we are applying this in an interaction of 2 layers, no more than 2 layers, and the bottom layer is the original image. Does that make sense? So like, you can think of changing your composite mode here. You can think of this as building a simple layer mixture structure like this without having to take up that extra real estate and with having a few limitations imposed on that layer mixer structure. Limitation number 1, you are stacking 2 elements and 2 elements alone. Limitation number 2, you are only manipulating one of those elements in your layer stack. That is the topmost layer. The bottom has to stay the same. The bottom will not change. The bottom is just whatever the image was when it's being fed into that node that you're changing the composite mode of. Does that make sense? So there's no inherent difference. They can actually do identical things. It's more like if you were to run into a scenario where you're like, well, I actually want to have 3 nodes here. Or I want to do something like we were looking at a moment ago where I apply this LUT, but just with a little bit less strength than I had previously. Or rather with a little bit less strength than I'm applying to this node, right? Now, technically, you could still do this. Like you could apply it here and then do that layer mixer on top. This is actually we can round this out here. So let's just, this is a good place to land. So let's say we are in our luminosity composite mode, right? On the bottom layer of our luminosity composite mode, which is our color, we are applying this LUT verdigris at a key output gain of 0.25. On the top layer, we're applying that same LUT at a full strength of the key output gain, right? Let's see if we can recreate this. I'm going to copy this node and then delete everything else. So I'm applying this here. I'm now going to add a new serial node and set the composite mode to luminosity and paste this like so. Is that going to be the same? No, because this is already being applied to the full image. And I'm now just trying to alter that with what I'm doing here. So it does indeed, this is one way of confirming for us these limitations that I'm talking about. The composite mode in an individual node is great, but it is only going to allow you to blend 2 sources, and the bottom source is going to be a do nothing, same as input type of source. As long as you're operating within those, it can be a really great way of saving real estate and of, mainly saving real estate, but also just kind of simplifying what you're doing. I actually love using the color blend mode, for example, when I'm adjusting contrast. Like if we look at, wake up panel, if we look at, reducing our, or increasing our contrast here. Actually, am I getting that right? I think what I mean to say is my luminosity, yeah. So you can definitely go too far with it, but this is a way, like you can look at my vector scope and see that it's doing its best to preserve my overall signal as I'm adding or reducing contrast. Now, you can totally push this too far and break it and make it look weird, but as long as you're doing little nudges, this can be a great way of not making an adjustment that then introduces the need for a compensation. Like we've all had this before where you're like, oh, I am pulling out, let's do this to make it even more obvious. Let's add my look back in here. And we'll go back over here. You'll say, okay, I am pulling out contrast, but I'm also kind of like losing some life in the image. So I now need to add some saturation back into it, right? Well, one way that you'll do this, and in fact, something that I do with blend modes all the time is like, I'll make the adjustment. And then if I notice like, yeah, but it's starting to get kind of anemic with the color, I'll just change that node after having made the adjustment to a luminosity mode. And now it's going to hold on to some more of that color. So that can be a fun thing to play with as well. Okay, guys. Was it fun doing node mode? That was a fun chat. Hope you guys enjoyed that. Hope you picked up a little something new along the way, or maybe just a different way of looking at nodes. It's a great topic to discuss because it's the whole building block of everything that we do in Resolve. So I hope you guys enjoyed the sesh. Thanks for bringing your questions and your ideas to the conversation. Thanks to my buddy Annie for co-hosting with me, and I will see you guys here on the channel and back for some more regular cadences of grade school very soon. Yeah, it's been, I think as I shared probably in our last edition of grade school, it's been a very crazy start to the year for me and my family and our whole industry here in Los Angeles and elsewhere, but things are getting back into rhythm slowly, and I'm glad to be back with you guys and able to do grade school from the home office as well. And more fun stuff to come. More videos, more content. I'll give you guys some more updates on all the fun stuff going on here in our world. We've got lots of exciting stuff coming here in the next couple months on the channel and elsewhere with Cullen Kelly Color. Good to see you.